Adding and subtracting many fractions is a skill we use every day. Looking at the measurements of height, weight, or distance in the sports we play. Or in buying and preparing the ingredients of the food that we can make. The LCM of the least common multiple is the key, make no mistake. Okay, when you're singing this, take a deep breath. Change all the fractions like denominators with a pen. By writing the multiples in line, find the LCM, which is the LCD. To find equivalent fractions, figuring the answer and writing in easiest fashion or simplest form. Did you get that in one breath? Well, let's try it again. Adding and subtracting many fractions is a skill we use every day. Looking at the measurements of height, weight, or distance in the sports we play. Or in mind and preparing the ingredients of the food that we can make. The LCM and the least common multiple is the key, make no mistake. Take that deep breath.
Unit price. What a wonderful idea. I love unit price. In fact, when I go to the grocery store and I want to buy toilet paper or cereal, I actually look for the unit price. It's too complicated to figure out what's the better deal when you have different size boxes of cereal. But if they're the same size, or you break it down to how much it costs per ounce, which is the unit price, then it makes it much easier for me to realize how much I'm paying and what's the better deal. So if I have 10 oranges for $1.65 and I want to figure out the unit price, I want to know how much it is per orange. So I take the money, I put it on top because money is the most important thing in the world, and so money always goes on top. No, I do it because I want to figure out how much it is per one orange. It doesn't make sense to figure out how many oranges I can get per $1. Instead, the money is how much money I pay per one orange. So I want to divide this out and see what it is for one orange. Well, all this really is $1.65 divided by 10. When I divide it by 10, I end up with, I end up with 0.165. Well, how much money is that? I can't have a half a penny, which they used to call a hay penny. I can't have a half penny, so we round off, and this would be about 17 cents per orange. Number 2, light bulbs are sold at a rate of 3 for $2.07. How many can you buy for $4.83? So I'm going to put my money on top, $2.07 for 3 light bulbs. And my question is, if I have $4.83, how many light bulbs can I buy? So I could figure out the unit rate, take this and divide it down to out of 1, and then I can multiply to figure it out and see how many I can get for $4.83. The other option of how I can do this is if I don't need to find the unit price, which I did in this one. In this, I could instead just do cross products to solve. So I have x times $2.07, which is $2.07 x, and that's going to be equal to 3 times $4.83. Looking at this already, I can figure out logically if it's $2 for 3 pounds and it's 4.83, so it's almost $5, this is probably going to be more than 6 pounds, okay, maybe even 7 or 8 pounds. So I'm going to keep solving. I have 2.07x equals, and 3 times 4.83 is 14.49, which we could do all the multiplication for and solve. And if I still want to get x by itself, last step, divide by 2.07, divide by 2.07. And as you can see, let's see, 7 goes into 49 7 times, and 2 goes into 14 7 times. So this is actually going to work out really nicely, and it equals out exactly 7. And we were talking about light bulbs. Number 3, a toy car can travel 6 m, that stands for meters, per second. How far does the car travel in 2 minutes? So the first thing is we need our formula, which is Distance equals rate times time. You should have heard that in science class. Okay? The second part is we need to plug in what we know. We're trying to actually find how far does the car travel. You're trying to find the distance. Great. So the question is the rate. Well, they already tell us it's 6 meters per second. How much is per second? That's in 1 second. Now what I notice is it's asking in 2 minutes. So I think before I even solve this, I'm going to change this 1 second into minutes. So what I know is I can multiply this by so many seconds, crossing out the units of measure and cross it with minutes. Well, how many seconds are in a minute? Or how many minutes are in a second? Oh, there's 60 seconds in 1 minute. So when I multiply by this, which is called unit analysis, this is as if I'm multiplying times 1. And all I'm doing is changing the seconds into minutes. And then I'm going to multiply times time after. Although I could tell you what the time is. The time is 2 minutes. Let's go for it. Let's try it all at once. Times 2 minutes. So when I solve this, I see that the seconds will cancel out. And in fact, whoa, this is cool, the minutes will cancel out. So all I actually need is 6 times 60, which is 360, times 2. And the only units of measure left are these, meters. And would distance be some number of meters? Yeah, so what's 360 times 2? That's 720, and we're talking meters. That's how far the car toy will travel if it's going 6 meters per second. That's really fast, 6 meters per second. If it's doing it for 2 minutes, it's going to go 720 meters. Thanks.